All right, section 9.6 in your textbook. The title of the section is Finding the Area of a Parallelogram. Before we can go talk about finding the area, we need to decide or to define what is a parallelogram. And a parallelogram, by definition, the opposite sides are parallel. And we denote parallel by these little tick marks. They're little arrows. And if you'll remember, parallel lines never intersect, they never cross. So the opposite sides are parallel. Those two sides are parallel, and these two sides are parallel. Okay, I like to think of it, it's a rectangle, and the base has been glued to the ground, and we've pushed the top corner and made it into a slanted quadrilateral. All right, what is the difference between a parallelogram and a rhombus? If you remember the other day, we talked about a rectangle and a square. A square had all four sides that were equal length. Same thing with a rhombus. Not only do we have opposite sides are parallel, so we have this relationship, but in addition to that, we also know that all four sides have the same measure for a rhombus. All right, concept number 2. The area of a parallelogram is the product of the base and height. Base and height. Okay, if you remember the other day on a rectangle, I told you I like to label it as the base and the height. And we said the area of a rectangle was base times height. Okay, I'm going to show you here with a parallelogram. So here's our parallelogram right here. How do we find the area of that thing? Okay, here is if I drop a line straight down, do you see this triangle? I'm going to pick that triangle up. I'm going to cut it where that dotted line is with my scissors, and I'm going to go put it right here. Okay? So now this piece, this whole piece is gone. Do you see now that I have a rectangle? Here's a rectangle. Huh. What did we say the area of a rectangle is? The area of that rectangle is going to be its base times its height. All right, now I'm going to undo that yellow part and put it back over here. So now this is gone. And I've put it back over here. All right, so I still have the height, and this is what's kind of confusing. The height is this distance here. So over here, it's this distance. Do not get confused with the length of this side. That's not what you're wanting to use to find the area of a parallelogram. All right, let me clear all this stuff out and label it. I want you to label the base, which is down here. This whole length is the base, and the height is right here. So the area is equal to the base times the height. That in orange is what you need to have on your sheet. If you put the other stuff, great, but the stuff in orange is what needs to go on your sheet. Area of a parallelogram is base times height. All right, let's go do some examples. Find the area of the parallelogram and be sure your answer includes the correct unit. Okay, number 1, my base is 5 inches and my height is 2 inches. So the area of my parallelogram, remember that the formula says base times height. I'm going to do 5 times 2, and 5 times 2 is equal to 10. Since we're finding area, our answer has to be in square inches. And we write that as inches with a superscript of a 2, inches squared. Number 2. We want to find the area. The base of the parallelogram is 11.7 centimeters, and the height is 20 centimeters. So area of a parallelogram is equal to base times height. We're going to write 11.7 times 20. If you can do that in your head, great. If not, I'm going to go over here and do 11.7. That doesn't look like a 7. 11.7 times 20. Row of zeros. Put a placeholder. 2 times 7 is 14. 2 times 1 is 2 plus 1 is 3. 2 times 1 is 2. Now I need to go add that. I had 1 decimal place, so moving my decimal over 1. My answer, 11.7 times 20, is 234. Now what are my units? Each side was measured in centimeters, so my area is going to be centimeters squared. Number 3, find the area of the parallelogram whose base is 10 1/3 feet and whose height is 5 2/3 feet. The area of a parallelogram is equal to base times height. I don't like mixed numbers. I have to change those to improper fractions. 10 1/3 feet. I keep my thirds. 3 times 10 is 30, plus 1 is 31 thirds. For 5 2/3, I keep my thirds. I do 5 times 3, which is 15, plus 2 is 17. 5 2/3 as an improper fraction is equal to 17 thirds. Okay, my area is base, 31 thirds, times height, which is 17 thirds. Multiplying straight across, 31 times 17, I'm going to go do over here, 31 times 17, 7, 21, placeholder of a 0, 1, nope, 1 times 1 is 1, 1 times 3 is 3. Add those two, 7, 2, 5. My numerator is 527. My denominator, multiplying straight across, I get 9. My answer is 527 ninths. What's my unit going to be? Feet squared, because I'm doing area. I have to be in square feet. Okay, number 4. Given the area of the parallelogram, I want you to determine the missing dimension. Okay, let's go look at our picture. Here's my parallelogram. I know that the base is 11 meters. They gave me the length of this side. Do you really need that to find the area? And the answer is no. So this is just like extra information. The height that I'm trying to find is right here, and I labeled that as H. So we know that the area of a parallelogram is equal to base times height. It gives me the area is 77 square meters. So I know the A, I can replace it with 77. We already said that the base of that parallelogram was 11 meters. So the B can be written as an 11. What we don't know is the height. So our mathematical equation becomes 77 equals 11 times h. To solve for h, we need to do our railroad tracks. To get the h by itself, right now we're multiplying, so we need to divide by that number that's in front of the h. But what we do to one side, we have to do to both sides. 77 divided by 11 is 7. 11 divided by 11 is just 1, so we have 1 times h, which is just h. So our missing dimension, our height, is going to be 7 meters. Here's our answer. Our height is going to be 7 meters. Last problem, number 5. The area of the parallelogram is given to be 24 square feet. I want you to find the base, B, if I give you the height is 1 1/3 feet. Okay, I know the area of a parallelogram is equal to the base times the height. The area I'm given is 24 equals, the base I don't know, it's B, times. All right, let's go look for the height. The height is 1 1/3 feet. I can't write 1 1/3 over here. I have to change this to a mixed number. It is a mixed number. I need to go to an improper fraction. I'm going to keep my denominator of 3. 3 times 1 is 3, plus 1 is 4. 1 1/3 is equal to 4/3. That's the number that I'm going to put here, 4/3. Here's my mathematical equation, 24 equals B times 4/3. Now I want to do my railroad tracks. To get B by itself, I need to divide both sides by 4/3. Okay, this is a great review. Over here on the left, 24 divided by the fraction 4/3. How do you divide when you have fractions? You're going to say that that equals 24 times, and reciprocate that fraction, 3/4. So this is 24 over 1 times 3 over 4. Okay, you can simplify this a little bit first. You see that 4 goes into 24, 4 goes into 4, 1, 4 goes into 24, 6. Now I can go straight across. 6 times 3 is 18 over 1 times 1, which is 1. 18 divided by 1 is just 18. So my answer is going to be 18 equals B. So now let's answer the question. I wanted to find the missing dimension. My base is going to be 18 what? What's my unit? 18 feet. Good. That's my answer.